This is the afternoon session for immersive interactive 3D tools for infrastructure. We only have two presenters today. Unfortunately, Chris Leone with WSP is not going to be presenting, so we have Mark Day and then Steve Ryan that are going to be presenting for us. What we'll do is let them go through their presentations. Maybe we'll have more time for Q&A. And of course, if not, then we'll just go ahead and finish up early. So Mark is going to start off for us, and he is with Greenman and Pedersen, and Mark has been with GPI for 20 years. He's, excuse me, he's a director of application development and has over 20 years, has experience in planning, development, implementation, implementing complex transportation systems. At GPI, his responsibilities include leading the development of software, visualization applications, development of AI data solutions, and implementation of LiDAR and big data algorithms. He's been involved in over 50 transportation visualization projects throughout the United States. So we're very excited to hear Mark's presentation about big data, LiDAR collection, and visualization. Mark?
Thanks. Hey, everybody. So just before we get started, just a show of hands, who here knows what LiDAR is? Okay, everybody, good. Okay, who's ever worked with mobile LiDAR? Okay, less. And who's ever tried to visualize mobile LiDAR? Okay, so some of you, well, you know my pain. Some of you know my pain. So what we're going to talk today is visualizing mobile LiDAR, some of the problems, some of the solutions we came up with for our project for Massachusetts DOT. So I'll go through this really quickly. LiDAR, light detection ranging, right? Basically, it's a sensing technology. There's a sensor. It sends a beam of light out. It hits something, reflects back. We know the angle to send it out at. We know the speed of light. We can establish a position there. Now, different LiDAR systems operate differently. Terrestrial LiDAR is a tripod, right? That'll scan one time, senses a bunch of points. Aerial LiDAR is the same thing on a plane, and mobile LiDAR is the same thing on a vehicle. Our mobile LiDAR sensor sends out 1.2 million pulses per second. So what it does, it generates these massive point cloud data files. So this is sort of the crux of the problem is the data is so massive it's almost impossible to work with. Those are normally coupled with imagery, so you can either colorize the point cloud, or you can also use the imagery to sort of navigate through the point cloud. All right. So I'm going to tell the whole story in context of a project we worked on. The project is a Massachusetts DOT SMAIS project. And what this was, it was a statewide asset inventory for traffic signs and roadway structures. So it was an RFP process, and what they wanted someone to deliver them a signed geodatabase to plug into an asset management system that consisted of every state-owned traffic sign. It was over 6,000 centerline miles and so 16,000 miles of driving. So it was a large project. They want to also do nighttime productivity and put the whole thing in an asset management system. And then it was supposed to be done in 2 years. So we sort of came up with the concept that if you're going to drive an entire state, you may as well drive with sort of the biggest, baddest piece of equipment you can find, which was this LiDAR. So you can see a LiDAR in here. It's got 4 35 megapixel cameras, 2 front-facing, 2 rear-facing. And then it's also got a LiDAR sensor on the back that scans at 1.2 million points per second. So we use this to drive the entire state. Okay. So just to talk about the data a little bit. So the sign database itself is 250,000 signs. It's not really a lot of data, right? That's less than a gigabyte of data. But in order to generate that 250,000 signs, we collected 1.6 quadrillion points of information. So there's an absolutely massive point cloud, right? The data set's over 80 terabytes, and over half of that is LiDAR. There's also over 6 million images. So how do we deal with this? 80 terabytes is easy to say, but if you actually, I don't know how old you guys are, but if you put that on a CD and put the CD in a jewel case and stack the jewel cases, it'd be taller than any building in the United States. So it's absolutely massive, right? So sort of how do we deal with this? Well, just to sort of illustrate the problem, I'm going to show you a mobile LiDAR data set in ArcScene. ArcScene is an Esri product. It's okay at showing 3D data. It's not the best, it's not the worst. Oh, sorry. How do I get the video to play up there? Anyone have any idea on that?
Is it requiring internet?
No, it's playing on the screen here. Small screen? I'm just gonna get rid of the PowerPoint for a second. That's probably
Yeah, maybe that's,
I'm just gonna close that.
we're still seeing this.
Okay. Any idea what's going on here? Do we have an AV person possibly handy here?
There should be a mouse.
Just do it.
Like a virtual mouse.
I've got a mouse in my hand,
Okay,
but
it's, okay. Are you able to click in your computer?
oh yeah, absolutely. I can, but can't even see my computer up there anymore.
Because it's this.
Right.
That's
so how
what
do
we're
we?
seeing.
Oh, you're not even, this is not on this?
It was. It just stopped.
Okay.
So what's running now?
I don't know. All right. Well, we'll let that go sorted out. Not much of a presentation without the PowerPoint. So anyway, so what we're going to show here is the data loading in ARC scene. Generally, the way you can sort of think of it is that most computer programs can load between, sort of render between 1 million and 20 million points on screen at a time. ARC scene is about on the lower end of 1 million points per second, or points on screen. So if you think about that, that connects back to actually only 1 second of scanning. So you see the problem. We can basically drive for 1 second, and that's the maximum information we can sort of send to the screen at one point. Anything on the AV here?
The tech support is on their way.
Okay. Let me try a couple things here so I can kind of. Oh, okay. Cool. All right, let's just try to do it this way. Let's see what happens. All right, there we go. All right, cool. So, okay, this is LiDAR ARC scene. So this is actually I-4 in Orlando. So this is about half a mile of driving. So you can drive that in about, what, 30 seconds or so. And you can see the issue already. We're looking at, it's just an interchange. That's an overpass there. And you can see it sort of filling some of the information in. So he can't really get this is not a good visual representation of what it is, but this is his best law software can do because the data is so massive. What it's doing is something called point decimation. So it's actually basically trying to figure out from where the camera is and where you're looking, what the best sort of million points it should render and sort of trying to give you a structure like that. It's not very compelling. All right, so I'm just going to stop this now.
So are you good with the video or just doing our technical?
I think we're probably okay. We'll find out, I guess. Yeah, no, it seems to be okay. It's fine.
Okay.
Okay, so we didn't get into this project without having a basic plan on how to do this, right? So essentially, you remember I said it was imagery coupled with LiDAR, and that's how we collect, right? Well, if you see, basically what we used to do, we would sort of manually sort of step down the roadway, right? So that's the imagery up on the upper right. And then essentially you find, say if you're extracting data, you're extracting traffic signs, you find a traffic sign, then you draw a cross section. And then you bring up a profile view, which is down here, and then you can use that to measure stuff. It works, it's incredibly inefficient, right? So what we wanted to do is we wanted to sort of figure, is there a way we can do this like sort of street view on steroids? Can we actually just sort of fly through the LiDAR and use the LiDAR sort of actually just virtually driving down the road, right? So I ended up going to a conference, this was about 4 years ago, and I met a guy named Bruce Dell. He runs a company called Euclidean. Euclidean builds hologram rooms. So I don't know if you've ever seen like Star Trek and the Holosuite, or the Holodeck it's called. It's basically they're building that. And so we sort of got to talking, and what he realized is that his software could render massive amounts of point data. So okay, this is fantastic, we can use this, but what it couldn't do is do anything else. So it could display all this data, but we needed to extract data. We're looking to make money by extracting signs, pavement, roadway structures, all that sort of stuff. That he's pulling information out of the data source. He could display it, but he couldn't do anything else. So we sort of kept talking, and we worked with him to build what's called an API. So essentially, we were able to build a bridge between software that we were going to write and their existing holodeck software. The idea we built this bridge, we could communicate and tell the camera sort of where to position itself in LiDAR and let their graphics engine do the rest. So we worked on this for a little bit, and they actually turned around pretty quickly, and we sort of used this as a foundation, what we called our high road platform. And now I'm going to jump back into a video, so we'll see what happens here. Okay. So this is HighRoad. So this is the software we actually designed to be able to do this entire inventory. So you can see what we're going to look at here is we're going to look at I-93 northbound coming out of Boston. And you can see, so there's our high definition imagery on the left-hand side. This is actually how we go through. So you're driving from Boston up to the New Hampshire border. That's about 40 miles or so. And so we're able to go through and sort of start stepping through the LiDAR. We've got back-facing, forward-facing cameras, rear-facing cameras, and we can start stepping through the imagery, right? It's not that big a deal. You've seen this sort of stuff before. But what we're also doing on a separate screen is actually sending ourselves through the LiDAR as well. So if you remember back to that arc scene video I just showed you, and you look at the difference there, I mean, we're basically flying through this in real time. So what we're able to do is we're able to use it in constant. What we can do is we can go through and we can actually extract assets very, very quickly. I'm just going to go through, I'll show you actually a quick model of how we do it. So essentially, you identify an asset in the imagery. We can take a look in the LiDAR. We can add any type of asset we want. And we go into the LiDAR and perform all our measurements. So what we can get here is the height of the sign, the width of the sign, the vertical clearance, all the information we need, but then we can also use the high resolution picture to actually have a great understanding of the conditional assessment of the sign. So you can see I'm measuring across the sign there, and that gets me the height and the width in one measurement. So it's all about having an organized manner to actually go and collect this information. Okay, so that's enough of that video.
So, question?
Yeah,
Is
sure.
that just the raw point data that's being rendered?
It's actually, no, it's processed. So it is no longer like a last file, for example. So we have to process that out. So it's a good question because essentially we're collecting almost survey grade data. If you have once it gets transformed, though, it's actually a separate proprietary data set. Essentially how it works is they build an index off the point file. So at any point, it's like Google, you search Google, you don't search Google, you search an index, right? So this, at any point, they can tell you what are the 2,000 or 3,000 pixels you're going to see from any camera position. So that's sort of how their technology works, as far as I understand it. Okay. So what I thought I'd do is I'm going to show you. We're going to do a bit of a live demo of their engine. It's pretty phenomenal, and I'll show you some additional visualization uses they came up with. So the project's over. We delivered all the LiDAR, all the imagery to Mass DOT. And we actually use a compressed version, so everyone at the DOT who has access to it has a little sort of hard drive that they use, and they just plug it into their computer that contains all the data they need. All the high-res data is up on a server on the clouds. They just pull down what they need. So the idea was to get it out to as many people as possible, because they're going to know better what they can do with this information than I do, right? So the deliverable was a signed database, but we also delivered all the LiDAR, all the imagery, so they were able to use that. So what I'm going to do is I'm going to jump out of this. Hopefully this shows up nicely. Okay, so one of the really cool things about working with a gaming company is that all this stuff works on like an Xbox controller. Yeah. So if you look, so this is, we're looking here, this is, in Massachusetts, this is Cape Cod. What's the bridge that goes to Cape Cod?
Bourne Bridge?
Okay. So that's that bridge there, and we're looking at, I think, about 50 miles or so to the tip to Provincetown. So you can see the rendering is you can see the massive amount of detail we're talking about here. So we can go through the bridge. And I can fly. It's basically what sort of that. Yeah, exactly right. I used to be really good at this, but not anymore. So anyway, so we deliver this to DOT, and they've got this entire wealth of the entire state. Every state-owned roadways are at their fingertips. So it's sort of like, well, what are they going to do with it? So John Diaz and I were at a conference, and somebody came up to us, and their job was they were looking to locate CCTV cameras. They were going out with a bucket truck. They'd take the bucket truck to the location. They'd actually go up 40 feet. They'd sort of see what they could see, and they'd go back down and they'd mark that as a potential location, right? So the idea was you could do the exact same thing with this, at least to get a preliminary measurement. So you go to, say, we're going to go to this location. I'm going to look up. I can take a look around and sort of see what I can see from there. So this gives that a really easy sort of visual tool, right? You'll see everything. So that was sort of the first one we saw. And again, it's just simply to explore, and they also have the images, so they can see everything in concert. So I'm just going to pop out of there for 1 second. What I'm going to do now is I'm going to load a different data set. All right. So this is, we're looking at here, this is the George Washington Bridge. So we do a lot of work with Port Authority. We're on the George Washington Bridge right now. So this is George Washington Bridge. That's the Bronx over there. That's New Jersey there. And this is a super high detailed scan we're looking at here. So let me go down. We can actually drive down the GWB here. And the way we scan is we did it twice. So we scanned once, we were on the top deck, we came down below, and we're actually on the lower deck there, so we can sort of fly back and forth. And again, this is just, it's floating point data, right? It's actually geographically registered, so it's in the right location, but there's no sort of boundary. This is just a series of points. It just looks, it's so dense that it looks like a real structure. So, again, we're always looking for other things to do. So, this is very high-end software, right? It's going to need a graphics card, you need to be able to use it. So the idea was, we're trying to pass the headset around. So the idea was, well, how can we possibly take this information and sort of turn it into something that is more accessible, more democratic, more people can see. So what we did is, I think a lot of people here have demonstrated those like 360 images that people are using, and they're awesome. They're great things. They're very low bandwidth, can be used very easily. So what we were able to do is use that same concept with the LiDAR. So what we can do is instantaneously, I can click a button, and I can generate a cube map, so you can see this entire scene in VR, which provides going around in that little handheld cardboard there. Just pass it around, and people can take a look. And all right, so I'm going to jump back into the PowerPoint for a second while it's going around. Okay, so the last thing I want to talk about is object classification. So this process was, we drove the state, we had an army of guys, sat down, basically virtually drove the roads and extracted sign information and roadway structure information. It's an inefficient process, right? So the idea is, well, how can we leverage some type of computer intelligence to be able to do this for us, right? And so there are some companies that actually do some stuff with LiDAR and artificial intelligence to try to do sort of feature extraction. The problem we've seen with all of them is they fail at scale. So when it gets massive, when it gets statewide, it's not really applicable anymore because the data is so large. So the interesting thing about how this software works is, I think we mentioned before, it's an index, and it basically sends you the proper 2,000 by 2,000 pixels you might need from that location to show you an image. So what it allows us to do is it allows us to take it a step further and actually bring those images out of the software and then use those with sort of classic image recognition techniques. So I don't know how much you know machine learning and AI, but one of the big sort of like early tests of it was you show the computer a picture of a dog, right? And it can say, okay, that's a dog or that's a hamburger, right? And the way you do that is you feed a bunch of training images, and then it gets a percent, probability that it is a dog like the other ones, and that's how it matches them. So because we can now pull all the images out of the LiDAR from a roadway perspective, we can actually do all this from giant LiDAR data sets. So just as some preliminary numbers we've got, so we're doing this with NJDOT right now, New York City DOT. These are some of the sort of probabilities we've got. So basically, we can identify manholes 99.9% of the time. Ramps 99.8%, we're going to work with ADA ramps, so it's the ability to be able to go through LiDAR and figure out what all those are. Crosswalks and cars. So the idea is, because we've sort of gotten LiDAR out of its sort of black box where nobody can deal with it, we can sort of expose it to all these other sort of ideas like AI and deep learning and feature extraction. So that's pretty much all I wanted to cover today, but if anyone has any questions, I'd be happy to answer them.
I have a question. What's the integration opportunity when you were showing, kind of going through the game and pulling in, utilities? You had the power overhead.
Sure.
Is it possible to get some information attached to those objects?
Absolutely. I mean, so the idea is, if you've got a point cloud, right? It's just dumb points. Now it looks really good because it's got an intensity and you can color with RGB too, so it looks realistic. But that power line is just a series of points that looks like a power line. So what we have to do, and what a large part of our job is, to actually extract data out of it. So you have people sort of like trace the power line or draw the pole. It's like there's a pole here and it's 55 feet tall, that sort of thing. You put that into a database, and then you can associate information, like, for example, power lines with who the provider is, that sort of thing. So that's why going to this sort of automated feature extraction, where we can take up so much more data so much more rapidly, it allows us to build like a 3D model out of a dumb 3D point set. So that's the idea. So, yeah.
So one slide back, it looked like on your feature extraction, your car had some color. Were you using color pixel with a photo overlay?
Yeah.
With the LiDAR?
Yeah.
And okay, because that would probably help your feature extraction.
It does and it doesn't. Most of the work we do is signs, just how it is. And signs are really great with intensity. So a LiDAR can, that's basically with the reflection. You can look at the black and white colors, the brighter colors are higher intensity things. So signs pop out really, really easily. So it's actually better with that particular asset. But yeah, things like cars, ADA ramps, the biggest training item is the actual, the detectable warning surface, the pad. And so color on those is ideal.
I was wondering if you can use the reflection value you get back on the LiDAR for checking, like for assets on the pavement lines and stuff, or signs on if they need to be replaced.
Yeah, so we've looked into that using basically for science, for example, retroreflectivity. There are a lot of studies that do that. I don't know if it's, this is one of the things where there's these FHW mandated methods that you have to use. So you have to sort of get it certified. So it's never really come up for us, but it's a great idea. Yeah.
Did you tie all the LiDAR scans together, like down to control points?
Yes.
Or are they just relative to themselves?
So this is, the LiDAR scanner we use is a survey grade LiDAR scanner. And what that means is that any measurements within the point cloud are accurate to about 3 millimeters, so they're hyper accurate. It floats anywhere between 5 and 10 feet in absolute space. Okay, so absolutely it's not accurate unless you tie it down with ground control, which we did not do for a state level collect. It was going to be too expensive. So the idea was we're just going to get as best as we can in a modest amount of cost versus tying it all, but it absolutely is possible. I mean, we use this for survey all the time and it's fully tied down. Just we don't do 6,000 centerline miles of survey at one time. So. Yeah.
You can go back and tie those sections down anytime.
Yeah, you can. We've done some playing around with it. It's better to do it the first time, but yes, you can, right? You can basically, I mean, it's traditionally you get common control points, you set them out. You need a lot of control, so, but yes, you can do that. Yeah.
Yeah, I came in late, your automated feature extraction tool, is that something that's proprietary of yours?
It's proprietary, it's us.
And is it a service that you provide, if I provided you with LAS files or something like that?
Sure. Yeah, absolutely.
All right,
Yeah, no, I mean, absolutely.
we'll talk later.
Yeah, we're like, just to be, we are developing this now. So this is something we're working on, and we're looking for partners, we're looking for data, so absolutely.
Yeah,
I'll do it.
I'm gonna get you started.
Yeah. Yeah.
Could you expand on when you said you couple it with high resolution image that you're getting conditioned? Are you talking about just signs or what were you referring to?
It's so for this project, because the imagery, I don't want to go back to the video, but the imagery is so high definition, we can use it for a daytime conditional assessment for signs, for
For
example.
signs, and so it's sort of, is it automated?
No, not at all.
No. Oh, so
If
you're
we
visually-
have trained technicians sit down and say, that's good, that's good, that's 4, well, 1 to 5 score or something.
Oh, okay. That's why I just wanted to know what kind of,
Yeah, the other thing for this part, we did do a nighttime assessment as well of all these signs. That's a whole other animal project, so yeah, we did both.
so overall, which assets have you kind of toyed with?
For Mass DOT, we did signs, roadway structures, so that's like manholes, culverts, inlets, stuff like that. We did signals. We've done assets all over the country for lots of different. That was this particular project.
Those were the.
We've done guide rail, we've done pavement, we've done. I don't know, but I'm forgetting some, but lots.
Can I send it back to GWB?
Might be a dumb question, might be my answer. What do they do with the assets? They're just like, hey, we have it, this is cool. What do the DOTs do with the assets?
Okay, so they throw that into an asset management system where they can basically attach work orders to the assets. They can attach, for signs, for example, knockdowns, work orders. They can do degradation curves, so they know, for example, a south-facing red stop sign is going to degrade faster than a north-facing red stop sign because it's more sun exposure, right? Stuff like that. So it's being able to plan sort of their maintenance. So that's what I say. So, there's a lot of uses of this data. The biggest challenge, honestly, is after the initial inventory, is getting all the procedures in place that when you drop it into the DOT, they can work with it immediately. Because sign data especially goes out of fashion real quick. We did this project over 2 years, 2014 and 2015. I don't know if anyone lives in the Northeast, 2014 was like the worst snow year ever, so we had so many knockdowns that came through. So unfortunately, that first year of delivery, it ended up basically going back, and a lot of those signs had already been in place, and they didn't have the infrastructure in place to actually record the replacements. So a bit of a problem. Yeah.
So another question is, so you're using a LiDAR system that actually was pretty bulky probably. Is there, so it looks like marrying a LiDAR with UAVs would be a cheaper way to do asset management. But this is probably not going to give you, a UAV, probably not give you enough resolution.
The problem with UAVs, they give you enough resolution for sure. Like this is absolutely overkill for traffic science. Like we can do anything off this data. The UAVs, the problem with asset management is you don't get the range. So you can only fly 5 miles before it runs out of batteries. You also, mounting a LiDAR sensor on we do a lot of work with drones. They crash sometimes. LiDAR sensors are really expensive. So being able to mount, we had a proposal, somebody, the company wanted to buy a $250,000 LiDAR sensor that was like a helicopter. It's like, if the thing crashes, like it does happen. So yeah, we haven't really looked at UAVs for asset management just because of the ranges.
Any other questions?
And if anyone wants to play with the Xbox controller, I'll stick around afterwards. All right, thank you very much.